All right, so I'm recording now. So the question he asked was, okay, I'm going to start from the first one now. That what's the difference between integer and integer unsigned, right? Integer before, let me show you. I hope you can see my screen. I hope everybody can see my screen. Let me open a new. All right, so I hope you can see my screen, right? So take for example, we describe, let's say, use HR. Right? If they use HR, all right. So let's describe employees table. All right. Okay. All right. So we just described the employees table. Right? Can you see the integer column there? Right? The employees ID column, right, is integer unsigned. We have manager ID and department ID, integer unsigned. Let me open the SQL scripts, the HR scripts. Okay, good. This is it here. All right. So now, if you look at it, right, I want to compare these two to you so that you will see. Are you following me? Right? If you look here, basically, what is done here is that that's why we want people to join in early. Right? What is done here is that you're using an integer data type and you are saying that the size should be 11, right? The highest number in that, the number of digits or the highest number of digits that can be accommodated in that column is 11. But what does unsigned means? Unsigned is a data type attached to columns, which means it cannot contain what? First of all, it cannot contain negative value, right? When you have unsigned, it means that it cannot contain negative value. And only non-negative values are allowed, right? Then it says what the maximum range with unsigned integer is 0 to 4. What is that now? 4294967295. Right? What does that mean? Right? That means that right? That means that this, when you use integer unsigned, you can only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's it called now? 10 digits, right? You can only have 10 digits, right? But in this situation, right, these two are misplaced, right? Because what this person is saying, I didn't create this, right? What this person is saying is that I only want to use 10 digits, right? The purpose of this unsigned here, right? What this unsigned is doing here is only doing the first purpose, which is that it will not allow for negative values, it will not allow negative values. But you have assigned that what the length should be 11, right? But if you look at what I did here, right? Where is it now? Yeah, here we do not have any length. We only said integer unsigned. What that means is that this column cannot contain more than 10 characters. So the highest number this column can contain, this present one can contain, is from what? Is from 0 to this value. So the highest number the employees table can contain, right, is that we have from employees 1 to it's actually from employees 0, but from employees 1 to this number of employees. So we can have 4 billion, right? I want to believe that. Let me use comma before I can say. Yeah, 4,294,967,295 employees. That's basically what you're saying, right? So that is the highest number. So you cannot accommodate this value, this integer unsigned cannot accommodate the 296th employee or 296 citizen or whatever value you want to be. Are you following me? Right? It cannot allow that because it can only, first of all, allow 10 digits. So basically, when you use unsigned, what you're saying, unsigned means 1, no negative value can be allowed in that column. Right? No negative value can be allowed. 2, right? You can only store values with 10 digits, from 1 to 10 digits. Let's say 1 to 10 digits. Yes, from 1 to 10 digits, right? Are you following me? Right? And 3, right? 3, yeah, basically, this is actually the 2 of them, actually, right? No digits, no negative value can be allowed, and you can only store values from values with, or values between 1 to 10 digits. That's basically what it is. So when you have 11 digits, what do? Right? From 11 digits, right, you have to change to big int. You have to change to what? To big int. Please let me know if you understood that.
Yes, I understood. So I have a question.
Please go ahead.
When I use that big int for
Hold
the
on.
constraint.
Does everybody, hold on. Does everybody understand that explanation?
Yes, I understand.
Yes, sir.
The big int and the integer. Hello? Do we understand it?
Yes, sir.
Awesome. All right. Please go ahead, Ebube.
So the second
Ebube, can you go
question,
ahead?
yes, the second
Okay.
question about using varchar for primary key.
Yes. Okay. Yes. So you can use any data type for primary key, right? It is only if it's the only challenge you would have is if it is not unique. Remember that primary keys are supposed to be unique, so the values are supposed to be unique. That's 1. 2, irrespective of if they are unique or not, as long as the values have already been there, it will work. It is only maybe the person who is using it did not use it well, right? Maybe when you are stating it, it wasn't stated well, right? But most of the time, right, you have, of course, you can. Varchar allows for both numeric and alphabetical values and even special characters, right? So you can use varchar for primary key, right? Your constraint does not determine, or is not selective of what's it called now? It's not selective of data type, right? It's not data selective, or it's not data type selective, right? So you just need to be able to assign the primary key appropriately. Basically, that's just what you have there. Does that make sense? All right. Any other question?
I have a question, sir.
Please go ahead.
What's the difference between text and voucher and char?
What's the difference
Then between text
Okay, good.
and voucher
Difference
and
between
char?
text.
Yes, sir.
Text, voucher,
Voucher
and
and char.
yeah, good. Right? Awesome.
Yes,
Awesome.
sir.
I will answer that question. All right. The difference between text, voucher, and char, right? First of all, the similarity, let's start with similarity. The similarity. Okay, let me start with differences, right? In terms of text, text basically is a string of character, right? Text is string of character, strings of character, right? So basically, what text contains is your A to small letter A to Z, right? Capital letter A to Z, right? And 0 to 9 and special characters, right? So if you want to use text, right? Text basically is how we store alphabets, numbers that are in combination with alphabets and special characters and all of that, right? It is now the reason why the database that I said to you use text is because they are using a Postgre. There's a database called, or there's a DBMS called Postgres, right? I think yes, they use a Postgres, right? So text is what is like in Excel. In Excel, what you use to store your alphabet name and all of that is what is text, right? It's the same thing that you have here. But in MySQL, right? In MySQL, and I know Oracle has Virtual, even though they call theirs Virtual, right? Virtual 2, right? There are some of them that Oracle uses Virtual 2, right? But in MySQL, Virtual and Virtual 2 is the equivalent of text. So when you use Progress, and I told you when in the first class, right? I'm not sure you were in the first class, right? I said in the first class that data types are SQL is the same, except that a few of these SQL variants, right, have a few differences, right? One of the differences is this that we're looking at, right? Text as a data type in one one DBMS, and in another DBMS, it is called Virtual or Virtual 2, right? But they are the same. They're basically the same, right? They are basically the same, right? There's something we call big engines and small engines, right? Those are administrative tasks, right? In some situations, when the data is created, maybe the database you're using a database that stores string of character. This basically is called character literal or literal character. Literal. We call them literal or character literal. I prefer character literal, but the actual word is literal character, right? Basically, that is from letters and all of that, right? So basically, this text, right? When you create a database in form of text, right? You can, and you bring that database in that data into maybe you use the database that stores characters as text, and you bring that same SQL code and you bring it into MySQL, right? It will convert that text to Virtual because they are the same, right? Character, on the other hand, all right, character, which is char, right, is a so this Virtual is called variable length, like don't let me forget that variable length character. That's what Virtual is called, right? While char is called fixed length character, right? So text, take for example, examples of Example of text would be, you can say Susan, right? You can say text can be SO S0111112, right? This is text, right? This is text, right? It can be anything, right? Even your 123 that is quoted can also be text. Of course, they have to be quoted. So let me put them in quotes so that you understand what I'm saying. Text, they have to be in quotes, right? They have to be in quotes. So this properly represents. So this is the same thing in text as it is the same under what? Under VACHA, right? Under VACHA, right? It's the same thing. But for fixed character length or for fixed length character, basically you are saying that this character, even though they are characters, they have a fixed length. This is variable length, meaning that somebody's name. So if I say character, right? If I say character 20, what I'm saying is that this can allow what? Somebody whose name is what? AB. AB can be allowed. AB is acceptable, right? And if your name is A to, I don't know, maybe P or O, that is character 20, right? If your name has 20 character length, right, it will also accommodate it. But it cannot go beyond the length that you specify. So if you specify 100, it means that what? The length that you can specify, the number of characters that this data type can allow is 100. But in fixed character length, right? So what happens is that in this kind of situation, you can have a name as AB, you can have a name as AB Susan, you can have a name as this, and you can have, let me remove this now, right? You can have a name as my surname, which is a bit long, right? You can have a name like that as well, right? In this kind of situation, right? They can all be stored in the same database. You can see that their lengths are not the same. This is 2 character, this is 5 character, this is 5 character, and it's about 10 characters, right? So that's why it is variable, right? But fixed length is saying that they must have the same length, right? So if you say fixed length, character, if you say car and you say 2, right? What it means is that they must have the same length. So if you are saying ng, if you are using it for say state code, or let's say state code. If you are using it for state code, for example, right? And you are saying ng, right? You cannot say another place abj. I saw this somewhere in somebody's code on yesterday, right? This will give you an error because what you are saying is that the character length must be 2. So it has to be 2 consistently across board because car is what? Is fixed length character. Car is what? Is fixed length character. So it has to be 2 across board, right? It has to be 2 across board. It has to be 2. So whatever value you put, right? If it is 5, right? If you say 5, then they have to be 5 length character across board. So text and VACHA are the same thing. Text VACHA and car are actually the same thing, except that because the 3 of them can also accommodate number, right? They can accommodate numeric value, but it's just that the numeric values are not going to be numeric in nature. They're going to be character in nature. Are you following me? Right? So basically that is what it is. But the only difference there is that what car is a fixed length character, is a fixed length character data type. I hope that answers your question. I hope that answers your question.
Mr. I have a question, sir.
Hold on, Madam Susan. I hope that answers your question.
Yes,
Talk
but
to me.
even for VACHA, we write the number of characters. You know, we write the number of characters. So
I didn't get that.
I don't really get it. I said when we put the VACHA constraint,
Yes.
we put
VACHA
the
data
number
type,
of
not
characters.
constraint. VACHA data type.
Oh, sorry, data type. Sorry.
Yes.
We put the
Yes.
number of characters that will be there.
Yes.
So I don't
Yes.
see that much of a difference with the chart.
With the car. Yes, see, both of them are the same. That's why I said they are the same, right? Except that except that, see, this is the difference. The difference is very simple, right? In the situation of character, which is voucher, right? You can, in the same column, right? Look at, let me show you. Let me show you from, let me see, employees table, right? Do we have any car column there? I'm not sure. Okay, let me show you. Okay, good, country ID, right? Let's describe locations, right? Say select all from locations, right? Okay, let's describe locations first. All right, so look at the data type. How everybody is paying attention, right? You have integer unsigned as the ID. Then we have here, we are saying that the virtual, the street address is virtual 40. That is the length of the character should be 40. The postal code, the length of character there should be at most 12. This is at most 40. Then city is at most 30. Province is at most 25. Then we now have country ID as what? As 2, right? So let us select everything so that you understand. Let's select all from locations. All right. So if you look at it, look at this address, right? You see that it's a combination of numbers. All of the addresses are a combination of numbers and alphabets. Look at this one. It even have brackets. Can you see? Into bracket E. That's bracket there is a special character, right? Look at this one. It has hyphen, right? 40-5-12, right? So you see that a whole lot of them, this one has decimals, right? This one has comma, right? So you see that a whole lot of them have what? They have this, it's a VACHA is a combination of alphanumeric characters, right? Alphanumeric, alphabets, numeric, and specialized special characters, right? The same thing that you have here. Can you see M5V2L7, right? So basically, that's what that is, right? So, but if you look at it, right, the fact that we said that this column, let me show you. Right, the fact that we said that this column must have a length of 40, that's street address, must have a length of 40, right? You see that this is not up to 40 and this is not up to 40, but this one is longer than this one. So they can have variable lengths inside of them. But look at the character column, which is the country ID. You see that they are all 2 characters, all of them, 2 characters. If you try to put more than 2 into that column, it will not allow it because you have specified that this is a character column. It is not a variable character column. It is a char column. And the length that is allowed is 2. So every country code or every country ID must be 2. And that is what we do with it, right? Let me see if there's another example there. Char. All right, look at country ID. Let's look at country ID. Aha, so it's the same country ID, right? If you see country ID, same thing, right? Sorry. Oh, regions does not have character. So basically, what you have is that voucher are variable. The character, the text in the column, right, can differ in length, but it cannot exceed the length that you have specified. They can differ in length, but they cannot exceed the length that you have specified, right? But for character, it can only be what? The length. It has to be the exact length that you have specified, right? Does that answer your question, man?
Yes, sir. I guess it's
Awesome. Iceman, I saw my name. All right, talk to me.
Mr. Show, good evening, sir.
Yes, sir. Good evening.
Well, please, what does the create a view mean in SQL?
Yes, we've not finished create view, Abby.
Yes, sir.
Okay, let me answer create view. Since we've started talking about select statement already, right? Let me talk about create view. Views are, we consider a view a mirror into a base table. Let us look at the, so if I say select all from employees, right? Select all from employees. Right? You see that we have 107 what rows, right? But I don't want to. So I hired, or the company hired several new data analyst or database administrator or whoever is going to be using a database, right? And because this table contains sensitive information, so we consider the phone number column, right? We consider the phone number column a sensitive what column, right? We consider what the email address a sensitive what column, right? We consider the salary a sensitive column, and the people that want to work on the table at the moment, right, do not need to see those columns, and they don't even need to see everybody on the database, right, on this table. So I can create a view. A view is like you are creating a subset. You are creating a query, right? It's like a view is that you are creating a small query. You are running a query. You are creating a subset of the table. It's like a window to a house. Are you following me? A view is like what? It's like a window to a house. Let me show you what I mean, right? How do we create view? I'm going to say, remember I said what? View has to be based on what? So views do not have data of their own. They have their data comes from the what? The existence of an already what existing table, right? So let's create a view. So if I say create view, the name of my view is say let's say sales underscore department, right? That's the name of my view, right? Let me say sales underscore department. I say as select all. Oh, all right. Instead of saying select, so that you can understand it better, say select employee underscore ID first name. I want to remove the sensitive information there, right? Last underscore name, right? I'm not going to put email address and phone number and hire date because they are what? They are sensitive information. I'm going to say job ID, right? I'm not going to put salary. I'm not going to put commission. I'm going to say manager ID. Right? And I'm going to say department ID. Right, so let me break this down so that we can see all at a glance. Right, so I'm saying select all of these from what? Employees, where department underscore ID equals 80. So what will our business case be? Our business case will probably be create a view for the sales department, right? Create a view for the sales department. So I'm saying that, let me call this department 80 so that we understand what it is, right? So sales department 80, right? So we're saying that create a view as what? As select all from what? I mean, select first employee ID, first name, last name, right? Job ID, manager ID, department ID from employees where department ID equals 80. If I run this statement now, what you would have is a view, right? It says view what? Our view has been created. So if you come to view, right? Let me reload my schema. Right, can you see the view now? Can everybody see it? Can you see sales underscore depth 80? What that means is that I can now say select all from sales underscore depth 80. Can you see? What does that? What do you notice? You notice that the SQL statement goes into the employees table and fetch me these columns, right? It fetches me.
Mr. Show.
Yes, ma'am.
Good evening, sir.
Good evening.
Okay.
Good-
Yes, sir.
Yes, ma'am.
I was unable to see the screen, but I can see now.
All right. All right. So create view as sales underscore depth 80. What did we do there? Right? What did we do there? We just basically extracted these values, this data, all of this data for what? For the people in department 80, and we created it as what? As a small window, a subset of the data. What it means is that this data they cannot exist without what? The employees table. That is what a view is. So in some organizations, right, views are like security measures. Imagine that you're in a database, you're working in an organization where you keep sensitive data as such as the name of employees, their credit card details, their credit card numbers, their what's it called, the date of expiry, their CCV numbers, all of those sensitive financial informations that people have on their cards, right? And you have it on a database, right? And you just imagine that you just have that kind of database and you allow anybody to use it to access that database. All they can just be doing is just be shopping $100 on people's credit card. You can begin to sell people's credit card because what you have is sensitive information, right? So what do? In that situation? You can create a view on that data to remove or to eliminate or to restrict, not eliminate now, to restrict what the users or your system users would see. Are you following me? So you can use a view like in this situation now, right? So if I want you people to say, for example, I want people to work on this data now, right? I will not give them access to the employees table. I will only give them access to what? To the sales table, sales underscore depth 80 table, right? I will only give them access to that table. So all they just need to do is what? Is to be using this view. They don't need to see the original what or the main information. What they will be seeing is what? Information from the view. Are you following me? That is what they will see. Information from what? From the view. That's what they see. So that is basically what the view is. So we use views majorly as security. And we what? Views are created based on what? The existence of another table. The existence of the table they are created on is called the base table. So employees table here is what? Is the base table. Base table. I hope everybody understands that. If you understand that concept, please just raise up your hands. So let me see. Raise your hands up. Raise your hands if you understood that concept. Base table. View. Sorry. Raise your hand if you understood that concept. Awesome. You people are legends. Legends. Please let me know. I'm waiting for others to raise up. If you have questions, ask me on that concept. Right. If you understood it, raise up your hands. Right. If you understood it, just let me see a show of hands. Right. Raise your hand, raise your hand, raise your hand, raise your hand. I'm waiting for others. Elijah, do you understand it? Madam Anu, do you understand it? Awesome. Solomon, Moyo, Madam Olaide, Sammy, Madam Susan. We understand it. So that's basically what views are, right? We're going to give you assignments on views. We're going to create views, right? We're going to create views. So and also sometimes, right? The views are like they are used to store. Remember, I've told you that what they are used as measures of security, right? They are also used. Views are used as a measure of security. I've attended an interview. I did an SQL interview one time. The role was for a data engineer, right? And the guy was a Brazilian, and he was interviewing me, and he asked me a question about views, right? Of course, he's an experienced guy, and he told me that what are the rules that or what are the situations where you would use views, right? And I told him that views are I told him that views are used to store query, right? Views actually are used to store query. Views are used to store a query result, right? We'll talk about views more even when we get to Power BI, because query that we'll be working with in Power BI are actually views. They're actually views, right? Query results, right? Right? We use them to store query or query results, right? So when I mentioned this to him, it was like, okay, okay. And I told him that we can also use them as measures of security. He was like, really? I should explain. And I explained to him, he's like, wow, awesome. That he has never thought about it like that before. And I said, well, we use them as measures of security. If you don't want some people to see, you want to keep some data, right, secret, or you want to keep them, you want to put a restriction on them, and you don't want people to see them on your, you don't want your users or your admins or your database administrator or data analyst to have access to them. But you want them to work on the same table. You can create a view on that table, right? You can create a view on that table. So also, of course, we use views to store what? Results of query, right? Especially for what? For join statements, yeah. Especially for join statements. Especially for join statements. Especially for join statements. Right. So views are very important, right? Views are very important. I'm glad that we understood that now. Right? I'm glad that we understood that. Any question? You can put down your hands. Any question? Any question? Today we're answering questions. I'm hoping that people ask me questions that yeah, I know the questions that we've been raising are awesome, right? So please ask me more questions. Today I'm not going to teach any concepts, right? I'm not going to teach any concepts because I don't want us to struggle with what we have been learning, right? I want us to be able to understand it. Remember, I told you that what the goal of this training is not for you to go and at the end of the day go and read any mass materials or anything. You want to be able to get it once and for all, right? You want to be able to start a job on the next day and be able to do something, do your KPIs, right? Answer business questions with SQL, right? So basically, that's why I'm taking my time, right? We're supposed to have left SQL, but I'm taking my time for you to understand it, right? I don't mind extending the program, like I mentioned. I'm just making sure that we understand it. And because I know that people will not have time to go over it. And I don't want this training to just be one of those kind of trainings that you have done where you cannot remember the things that you have done maybe after 2 months of you not using it, right? So that is why I'm giving us assignment. That's why I'm bombarding us with assignment. And that's why I'm also using this opportunity to explain this, right? Instead of piling up theories and piling up concept upon us, concept on us, right? Let us deal with the knowledge gates that we have that are stopping us from moving to the next level. Let us just fix it once and for all. Then we can proceed after we have understood all that concept, right? We still have 3 things to talk about in SQL. So hopefully we can, of course, tomorrow we can start those ones. We'll start with joining tomorrow, subquery or joining, either one. We can go to either one, right? We'll talk about subquery or joining tomorrow. Then we'll talk about Windows functions as well. Talk about Windows functions as well, so that by next week we can start Power BI. Right? We can start Power BI by next week. So please ask your questions this night. Ask your questions this night. And also, we're also going to finish early so that you can go back and finish your assignment, right? I know that a whole lot of people have piled up assignments. So please, we're also going to use that opportunity to go and finish assignments so that when I give you assignment on subqueries and joining and Windows functions, right? It will not be too cumbersome. I don't want us to be doing assignments into Power BI as well, right? So let us deal with SQL and, put SQL, draw a content on SQL. So if you have any question, please ask me. Madam Udwak, do you have a question? I see your hand is raised. Do you have a question?
Okay, Mr. Sharon, thank you. Please, I want to find out. It might be a silly question though, but I need to learn.
No silly question, yeah, man.
Okay, I think last week assignment.
Yes.
My primary key, I just wrote primary key integer, and that's it. I didn't put the unsigned. So now
okay.
I didn't know how to go back to correct it to put unsigned.
Okay. So you are asking how do you do that, right?
And how do I correct it so that I can indicate unsigned on that primary key?
All right.
Like integer
Beautiful
unsigned.
question. Beautiful question. So let's create a table. Let's call the table. I want to replicate the scenario that you have. Let's call the table. What should we call the table now? Let's call it S, right?
Okay.
Let's call the table S. Right? So we're going to say S, right? Our first column is going to be, let's say ID, right? Integer, and we'll say comma, right? Then we'll say name.
Primary key.
Okay, integer, then primary key, right? Awesome. We'll say name, batch. Let's use let's use name, right? Let's say batch and the 5, and let's close that bracket. Let's end that, and we're creating that table as that, right? So our table, okay, I can drop it later. It's inside my HR.
Primary key not null.
Oh, okay. We did not. So you want to? All right, that's fine, right?
What
So let's say that, right? Let's say now say that. Let me put this together with this. So that, all right. Okay. You want us to put primary key not null, Abby? So
yeah, that's what I did. Primary key not null. So I
all right. Let me drop. Let me just drop the table that I just created. I'm going to drop that table. Gives me the opportunity. Good. Right. So I'm going to move into MTN, right, to run this. I don't want to mess up my HR schema. I'm going to say use MTN, all right. Use MTN so that we can use MTN database or MTN schema for that assignment. Let's see what table we have there. Okay, department and employees, right? These are just, so I can run this, I can create this here, create table. Right, can you see S is created here now, right? Oh, sorry, let me drop it again. I didn't add what you wanted me to add. Let me drop it again. Drop table. All right, so we say primary key, not null, Abby.
Yes, please.
Well, you really do not have to put not null when you put primary key, because primary key enforces not null, right? Well, let's just run it like that, right? But going forward, you don't need to add not null if you have primary key. Do you understand? So we've created the table now. Let's reload.
So now what you show us now is how to remove the not null and add the unsigned.
All right, awesome, right? So to do that, right, I've told you when you have an object, this is an object, right? This is a table, right? When you want to do that, you alter that table. So I'm going to say alter table S, right? Alter table S, right? Modify is the word here. I've told you, think about SQL like what? Like English, right? Modify ID, right? Modify ID, integer, right? Unsigned. Now I'm going to name it the way I'm supposed to have created it, and I'm going to say primary key without not null, right? If I run this now, what happens? Coming? All right, so primary key is there. All right, so what I'm going to do is, why are you still here? So I'm going to alter that table. I'm going to remove the primary key. Since there's already a primary key on it already, that's what it's saying. That's what it's complaining about. Unsigned, alter table ID. All right, so the table has been altered now, right? So let's describe S again. Right, can you see? It's unsigned now. Primary key is still there. It's unsigned now. So basically, all you just need to do is to modify that particular column, alter the table and modify the column and add your unsigned to it.
Okay, thank you.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Any other question? Right? I hope everybody is following. If you understand, if you understood that, can I see a show of hands? If you understood that, can I see a show of hands? Right? I hope that you are paying attention to those things so that you can use them in your assignment. Right? Awesome. 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 I'm expecting more hands. I'm expecting more hands. If you understood that, Viola, you don't understand it, Abby. I'm expecting more hands. I'm expecting more hands. Please let me know if you understood that.
Please, can you go by it one more time?
You.
Sir, it's not so easy to understand, though.
Oh, boy. Yoruba will say, oh, boy. Oh, boy. It's okay. All right. All right. If you, okay. If you, thank you, people who have raised your hand, please. Thank you. Thank you. You can put down your hands. If you do not understand that concept like Biola, please let me see how many people so that I can know if I can tell Biola to go and up transformer or we just continue. Because Biola is supposed to understand these things. Right? If you don't understand it, please raise up your hands so that I can continue. I don't know if you don't understand it. Biola, thank you. Good. Ebuka, can you please put Abebuka, you two do not understand, so I can roll blow for you there. Right? All right. All right. Madam Olaide, talk to me. Any other person? Some people are not raising hands here. In this place, to still raise hand, they will not raise hand. I will arrest you. All right, I'm just going to go over it again. So the question was she created a table, right? And she did not put unsigned. She just put integer, right? And she did not put unsigned to as part of the what? As part of the data type. Then she put primary key and not null, right? And she wants to now what she wants to alter the table. She needs to add unsigned to it so that she can specify the length, right? So the question is, how do you do that, right? So we created a scenario like that. We created a table called S, right? Where I created ID and I said integer and I did not put unsigned. And I put primary key and I put not null. And the first thing I said was that you don't have to put not null, right? You don't have to put not null if you have to put not null on the table once you have a primary key. Primary key enforces not null, right? Primary key enforces not null. So I said that. So in that situation, we want to remove the not null and we want to what? We want to put unsigned, right? So we created this and we described the table, right? And we saw that the table actually was created without what? It was without unsigned, just integer. Then I said that to fix that, you just alter the table, right? Alter the table S and modify. Modify, I've talked about this when we're doing DDL statement. That's like in the second week, thereabouts. In the first to second week of this training, we talk about creating tables and altering tables, right? We said when you want to alter a table, right, you can alter a table. By altering the table, you can add a new column, you can add a constraints, you can add several things to your table, you can modify a table. That is, you redefine the table already, the column, sorry, you alter the table and you modify a column. So you can add a column, you can modify a column that is redefine the criteria or the attribute of that column. You can drop a column, right? You can rename a column, right? I showed us all of this, right? You can check the scripts, the class scripts. Everything is inside this class script. Everything that you need is inside this class script. So you can check the class scripts for better understanding, right? So what we did was to modify ID. Can you see? We modified the ID, which is the column that had that issue. And we just added what? Integer what? Unsigned. So that what? You can have, once you execute that, you can now see that you have what? Integer unsigned as the data type there, right? Any other question? I hope Biola understands that.
Yes, sir.
Elijah, talk to me.
Yes, sir. In the assignments given to us,
Yes, ma'am.
in the ER diagram. You know, there are
Okay.
some links that link the tables together.
Okay.
If you want to write that kind of code, how are we going to reference them to each other?
Good. Awesome. Right. So basically, let me use the example that I used last class. Right. It's easier, and let me look for it. Open. Assignment 5, I think, was Able-based code. Was this the code? And where did I create the other statement? Away. I can't find the other statement. Was it this one? Yes, it's this code now. Coming. Oh, wow. Didn't I save it? Well, I can't remember. All right. So let's look at this situation, right? I think we created this table somewhere. Let me look for it. Hospital. Okay, yeah, this is the database, right? Let's use that database. All right, let's use that database. Use hospital. Okay. Or better still. Okay, let's do this way. Now that we've created a okay. Now that we've created a table called S here, let's create another table called create table T, right? T, and I'm going to say open brackets, right? TID integer this unsigned, right? Let's call it primary key here. Right. Let's say T underscore name virtual 40 not null. Right, let's say date of birth, date. Right, let's close this bracket. Let's say, okay, let's say T code. I don't know what I'm just, these things do not make any sense, but I'm just creating a table here. I'm going to say length is 2, right, and we'll close that, right, and terminate that, and we're going to run this table.
You did not put comma in the date.
Thank you. Thank you. You're following me. Thank you. All right. So we'll create that. So we have the two tables now. So let's insert into the first table. The first table is S, right? So you say insert into S values, right? I know that some of us values, right? S has what and what now? Our S table is ID and name, right? So I'm going to say ID is 100, name is Avga, right? Right. Let me copy this. Let me insert another one and another one and another one. So 101. Let's call this J. Let's run this. 102. Kenya 103. Congo. All right, so we've done that. All right, let's insert into T. Insert into T values, sorry. Don't mind me, I'm looking for where to copy data from. All right, so T has how many columns now? I think T has 4 columns. ID name, ID name. Okay, good. Right. Let me alter T before. Let me alter S. So alter table. S. I want to link the two tables together. So I need to alter table S. Right. Add column. T. What's that for T now? TID, right? Do TID integer unsigned. All right, so we describe we describe table S now. Just follow me. We have 3 columns, right? If we say select all from S, what do we have? You see that there's a column there now that does not have data. Right, no value, no value, no value. So let's update the table. Update table S. Set. Okay, hold on. Don't let me update the table yet. Let's insert into T now. Values. So TID is now TID is 1. My name is what? Ade. What else is there? Hold on. Let me look for it. Okay. Date of birth is 2022 -06 -05. Right. And code is let's say NG. Right. So let me copy this now. All right. So we call this 2. All right. So 3. All right, so we insert into the table now. So we say select all from T. Sorry. Duplicate entry. Oh, sorry. I didn't see that. 4, sorry. So select all from T. All right. Now, if you look at it now, I hope everybody's following me. Right. So if you look at the T table has an ID of 1, 2, 3, 4. And that ID has to go into what? Into the what? Into the S table, right? So what do? We want to update the S table. Update table. Yes. The table has to link with each other, right? The values, basically what it means is that in the S table is getting its ID, the TID from what? From the T table. So the values has to match, right? So if you say, let's say insert into S, update S, set TID equals to where ID equals 100, right? Let's copy that. Copy, paste. There are 4 of them. Paste, paste. All right. So let's do them one after the other. Right. Let's end this. Sorry, my update is not working. Let me check something. Why is it not working? Sorry, I included table and nobody told me. Update S, sorry. Try looking at it, pay. All right, so update this one, set the value to that. Done. Update table, set it to 1, where value is what? 101. Let's run that. Then update, set TID to 4, where this one is 102. Let's run that. Right. And lastly, update, set TID to 1, where this is 103. All right. So we select all again. Sorry, I say employees from S. What do we get? You see that it now has values inside of it, right? We can now what? Alter table, right? Alter table. Which table are we altering now? Alter table S. Are you following me? Let me copy the alter table statement sharply so that we don't waste time.
Sir, please, do I have to populate the table before I can implement this alter statement?
Yes, sir.
Okay, sir.
So that it does not mess you up, all right? Alter table S, add foreign key on TID that references TID. Right. So look at it. We're altering table S. Table S. Before we go to table S, table T, we will say select all from table T. Right. We select all from table T. Who owns the ID? Table T. Right. Table T owns the ID. But that ID is now reflective on what? On table S. So which means that which table are we adding to? Which table are we referencing? We are referencing table T on table S. Hence our what? Alter table. So you must know the link like that. So you don't just add primary, you don't just add foreign key. You must know where the table, where the column is coming from and where it is what, where it is going to. On this table, right, this is the T, T is the parent what? Is the parent table for TID. On what? On S, it is what? Is the child what? Is the child column, right? So it means that TID that is referenced in what? In table S is coming from what? From table T, right? If we run this, right? Can you see it is created, right? So if we go and check our reverse engineer the database, let's see what we have. Can you see? Can you see that the tables are linked together now because of that relationship? If I put my cursor on it, look at it. TID, TID. Are you following me? TID, TID. And that is because I understand the way they work. Where is it coming from? Can you see? Basically, I just need to push this off so that the relationship can be. Can you see that? Right. This is it appropriately. Right. Now, here it is a primary key. Here it is a foreign key. Can you see? Here is a primary key. Here is a foreign key. It's as simple as that. Right. So when you are creating your relationship, you need to know which one is, where is the ID coming from? Where is it being referenced? If you don't know that, it will mess you up. Now, why do we add? I like the question that Viola asked, right? Now, it is not necessary that you add your IDs. The reason why we add, it's not necessary that you populate your table before you add. Actually, it's not very professional that way, right? And that the reason is why it's not professional is that you might have duplication of value in your IDs, right? The reason why we do that is so that you can scale through the whole process of having errors. But you can actually create your table and add foreign keys to them directly, right? The reason why we usually do that is, let's go back to that model, right? Let's go back to that. Imagine that I did not, now, of course, I am experienced, so I'm able to do these things and know them like that, right? But look at the tables. Let's run the tables again. I saw it in, I think it's in able-based assignment, right? I saw it there, right? Look at it. If I run this, see, these values are coming from what? These values are coming from TID. They are coming from the T table. What it means is that they must match what? They must match what is on the T table. Look at what is on the T table. 1, 2, 3, 4. If they don't match, then there's a problem. Are you following me? So imagine that what is on the T table, what we have here is 1, 2, 3, 4. What I now have here is what I now have here on the T table here is values other than 1, 2, 3, 4, right? It will mess that data up and it will not allow your table to link with each other. Remember that the data that you are using on the TID of the S table is coming from the TID column of the T table. So their values must match. Please let me know if you understood what I just explained. That is foreign key in a nutshell. Raise your hands if you understand it. If you don't, let me know.
Mr. Ashim,
Yes, ma'am.
how are we going to know the table that we're supposed to reference to the other one?
It is already, let me see if I can bring in that schema, right? That's assignment schema. Let me see if I can open it up, right? I don't mind going through it. The signs are there already. It's just that we're not paying attention. Let me show you. The signs are there already. Look at, hold on, before we even go into that, look at our schema. Look at my own, look at my ER diagram. Can you see? Look, I want you to look at the this link. Look at the, what's it called now? Look at the end of each of it. Look at it at both ends. Can you see it at both ends? On the end where it is the primary key, see the sign there. Can you see that sign? That something like equals to sign that is there. On this end, can you see that it's scattered? Right? What you have here is a one-to-many relationship. One-to-many relationship. Can I add comments to it? No, I'm not sure. Let me see. Okay, good. Place a text box. Yes. Text 1. Comment. Right. This is a what? One, to many. That's a one-to-many relationship. That's what we have here. One-to-many relationship. Because how did I know? Are you following me? How did I know? Look at the end here. Can you see the end here? Look at it here. It's like scattered, right? And how do you know? Look at it here. Can you see? Look at these angles that I'm showing you. 1 to n is what? It says a non-identifying what? Relationship. That's a one-to-many relationship. This one is a one-to-one relationship. This is a one-to-many relationship. This is a one-to-one relationship. This is a one-to-many relationship. This is a many-to-many relationship, right? And so on and so forth, right? So basically, what we have here is a one-to-many relationship, right? So let me open that schema to you, that assignment schema to you. Desktop. There's that screenshot. Okay. All right, this is it. Look at it. I hope everybody can see it. I hope everybody can see it. Please let me know if you can see it. Hello?
We can see it.
We can, sir.
Right? This is like music, right? Same way people who plays music. This is music to your ears, right? What you have here is that you're interpreting. Look at it. Let's start from product. From products, right? What you have is what you have the product ID, right? Being a primary key column here, right? It's a primary key column here. Let me see. Can I edit this with all right, I can't mark this. Let me see. Yep. Can I write on it? I doubt it. Nah, I doubt it. All right, but look at it. Right? Just follow my cursor, right? The primary key column here is what? Is the product ID. Look at it, scattered. Mouse is scattered. Look at it. Let me zoom it. Can you see? Let me zoom into it so that you can all see. Can you see? It's one here. It's scattered here. Can you see that it is pointing to each other? So primary key product ID is now foreign key here, right? What do we have here? Supplier ID is on supplier table where it is a primary key. But here it is what? Can you see? It's a foreign key now, right? Category ID is a primary key on category table. Now it is what? It is on category what? Or it's on the product table as what? As a foreign key, right? Order ID from order details is now what? A foreign key where it is what? It is a primary key on orders. Can you see? Shipper ID on ship table on shippers is a primary key, but on what orders table is what? It is a what? It's a foreign key. Now, if you look at it, it is shipper ID here. Look at it, it's shipper ID here, but here it is what? Ship underscore via. So it does not carry the same name, but it is still the same table, because what matters is actually the value inside of it, not the name of its table itself. Of course, the name matters, right? The name matters so that you don't have ambiguous you don't have ambiguous name, right? But you can change the name as long as the data inside is the same. Which means that this data in the shipper ID is what is feeding the ship underscore via. Are you following me? Look at it now. You have the employee ID here as employee ID is is now a foreign key on the employee ID on the employee table is now a foreign key on the employee ID table, right? Look at customer ID. Primary key here on what? So if you look at it, the lines link the two columns together. That's how you know, right? But you see the edge. So you see that from the beginning here, it's a single value here, which is one too many. Oh, scatter DB, right? Right. Look at this now. Employee ID. Look at it. Employee ID. Employee ID is a foreign key on the others table, and it's also a foreign key on the employee's territory table. Can you see? So it is referenced in two places. And what the territory ID is a text column. Can you see text column on the territory table? It will be, can you see text as primary key, right? And it is referenced on on the employees underscore territory table. Then you have region coming from region ID to region as primary key on regions to to foreign key on territories. Can you see? Right? Then you can see the table. Now this is we'll talk about this much later. The employee ID is now reference to the table is joined to itself, right? It's now the same thing as as the report to. That's manager ID, report to. Can you see? This table is joined to itself, right? This table is joined to itself. I would not penalize you if you don't get this at the moment, right? This particular one, you can skip this particular relationship, right? But if you understand it very well, you can actually create it. It's not really hard. You're only saying that this table, no one, everybody should skip this part. I will explain it much later, right? When we all submit and I see what we have done. But you can try it, right? But when I've seen what we have done, then I'll be able to explain it, right? But what you see in that situation is that the employee ID is the primary key. But on the same table, it is now a foreign key in in the report underscore to column. So basically, that's how to interpret it. Right? That's how to interpret it. That's how to interpret it.
Okay, sorry, Mr.
Makes
Shaw.
sense? Yes, ma'am.
Can we now, based on her question, can we now say that for us to know where we are coming from and where we are going to, we'll take from the where we assigned as primary key to link it to the next table as a foreign key, right?
Yes. This is what you want to interpret. You're not just interpreting primary keys and foreign keys. This is what you're interpreting. This is what tells you, oh, this is the primary key. So when you're creating the tables, you're creating the primary keys already. You've created all the primary keys. But when you're creating the other table, so what it means is that when I'm creating the products table, right? In most cases, right? In most cases, you want to create the tables without the primary keys and foreign keys. You first of all create them because you have not created all the tables, right? If you create a primary key, what usually causes the problem? Let me show you, right? What usually causes the problem most of the time is that because you don't have a full glare of the table, right? You have created a primary key here, right? And when you are creating the table here, right? This other table, right? Look at it. This product table, you have the primary key. You are creating supplier ID, but the suppliers table, you have not even created the table yet, but you have supplier ID here. But this table, that is this ID is a foreign key. When the table is now linked together, but at the moment it is not even a existing table. It's not even an existing primary key. The table does not exist yet. So what it means is that if I'm to do this assignment, right, I'm going to first of all have to create all the tables without any constraints. Are you following me? I'll create all the tables without any constraint. When I have created the constraint, or when I've created all the tables without their constraint, majorly I can just create maybe the primary keys only, right? Attach the primary keys at the beginning, then leave all the constraints. When I'm done and all the tables are created, I can now begin to interpret this diagram to reference the foreign keys. So what it means is that now that all these tables are created, I can now look at product key and product table and say that, okay, the supplier's ID is linked to the product table. So I'm going to link the supplier ID on the supplier's table, which is a primary, the supplier ID on the supplier's table, which is a primary key column. I can now reference it on the employee, on the product table, where it is where it's a foreign key. I hope you understand that. I hope you understand that. Please
Can you
let me know.
explain all these primary foreign key with that code?
With which code?
The code I used to link those two tables, S and TID, I think.
I have explained
Can
it
you?
now. Come on, where have you been?
So I was
Yola,
here. What I'm saying is that you're
You were
saying
not.
primary key and foreign key here, and there you were saying S and T. So can you like write where we should put the primary key and where we should put the foreign key?
It's already there now. Look at it. When we created the table. Look at it. When I created this one, S table, the ID is the primary key, right? When I created the T table, the TID is the primary key. I'm just if I want to create hundreds of tables, right? That's how I'm just going to create them. I'm going to add them primary key, primary key, primary key, primary key, primary key, primary key, right? It is when you are done. That is why I gave you this. If you look at it, the tables have been created. The last statement that was created was that what the other table that was adding the foreign key was what was created last. Why did they do that? So that what the relationship or the tables already exist. Their primary keys already exist. You can now use that to link them up because why? You have that's why your ER diagram, you have to draw your ER diagram before you even start coding. This diagram is very important. You cannot start writing your codes if you don't have this diagram. That's why I usually send it to you. So it means that if I give you a project, right, and I say design a library system or a library management system, the first thing you want to do before you start writing any code is to develop the ER diagram. Generate the business point or the data point. What are the entities that are that you're going to create? What are the tables that are going to exist on the table? Split them out into into the possible split them out into the possible tables that you want to create, right? So you have all the tables, right? You can now begin to map out what is primary key and what is foreign key, right? You have that done and you have this old image settled. It is when you now begin to interpret it. That's basically what it is. So in this code, I showed you, right? What I did was that for every, can you see? Yeah, when I created S table, I specified the primary key. When I created, what was it called now? When I created T table, I specified the primary key as well. Does that make sense?
Yes, sir.
So once I know that, once I've created the primary keys and all of that, right? And I can see that, okay, T table, right? Look at it. When I look at it, right? It's all written here. It's all written here. When I created the T table, when I created the S table, I didn't create the third column because I didn't think it through. And that's because there's no ER diagram to support it, right? I'm just creating this out of my mind, right? There's no the third column didn't exist. But it is because I wanted to, when I now created the S table, and I discovered that, the T table, and I discovered that, oh, I want to reference this I want to reference one column on another column. Then what did I do? I add to what? Add a new column to the S table. All right. This column that I now add is now what became the foreign key for the primary key that I have created. So basically, I created the table S with 2 columns. I created the table T with 4 columns. But one of the table T column, which is the TID, is going to be is supposed to be a foreign key on the S column, but it's not even there. So what did I do? I added it. When I added it, what did I do? I now referenced it. I started into them. And after doing that, then can you see? I now inserted into all of it. The TID on the S table, it didn't have data. So I had to put values inside of it. When I did that, what did I now do? I created my I created my reference. This is where I joined the 2 tables together. What I would do, right? What I would do for us for this assignment is that I will look through everybody's. That's why I need you to submit, right? It's very, very important. I'll look through everybody's submission. The best submission that I see right? It's not that I want to give the person any price and all that, right? I'll look at the best submission. That's why I want you to put your mind to it when you're creating it. The best submissions, I'm going to edit them, right? I'm going to edit them and correct them and share the code with you so that you can just oppose it with what you have and make corrections for yourself.
Sir,
Makes sense? Yes.
Mr. Shem.
what you're saying in essence is that the foreign key is the one in brackets.
The foreign key is the one what?
In bracket.
Which bracket? Yes, yes, yes. On this place.
Yes.
In this place. Yeah.
Yes.
Yes. Now you are saying that this column on the S table is coming from this column on the T table.
Okay.
What this means, look at it. What this means is that, look at it. This is the notation. TID. We've not done joining, but let me show you. TID, S.TID is equals to T.TID. This is what that means. You see this statement that we ran here, right? This is what it means. S.TID is equals to what? T.TID. What does that mean? This is the TID column on the S table is equal to the TID column on the T table. That's simple. Do you understand, Abiola?
Yes, sir. Thank you, sir.
All right. Elijah,
Mr. Shem.
yes, please.
So, for us now to write a code on referencing, is it a must for us to put all our ID on primary keys?
Yes. If you want to, if the ID is going to be referenced on another table, it has to be a primary key. Yes. Compulsory.
Okay, sir.
Yes. That's why, and we call it normalization, right? Every table has to be normalized. I remember talking about it when we talk about the data model in the very beginning of this program. When we're talking about data models, right? I talked about it, right? You have to normalize your table. How do you normalize your table? Every table must have, is very compulsory, right? Even though some people create databases in such a way that some tables do not have primary key column, right? But it is not the best practice. Every table, right, must have a primary key column. The essence of the primary key column is that first of all, it uniquely identifies the rows in the table, unless the rows in the tables are not unique observations. That's when you don't need the primary key. But as long as the unique values are, as long as the table are, the columns, the rows in the table are unique observations, they are unique, you have to add the primary key to it. If you look at this now, every single table here is containing unique values. Products would have your IDs because what? Every product is unique. Category would have IDs because they are unique. Supplier will have ID because they are unique. Other details will have ID because they are unique. Others will have ID because they are unique. Shippers will have ID because what? They are unique. Employees territory would have. Now look at this column. In this old table, right? In this old schema, in this old scheme, right? This table is the only table that does not have a primary key column. The employees territory. In fact, that table does not even have a data of its own. That table does not have what? Data of its own, right? If you look at it, the first column there, employee ID, is coming from the employees table. The second column there, territory ID, is coming from what? It's coming from the territory table. So that's the only column in this table that does not have an ID of its own. Are you following me? Every other column, they have IDs. All the other columns have IDs.
Sorry,
Do you
sir, I
understand?
just
So how many tables are
wanted
here? 11 tables, and only one table does not have an ID table, does not have a primary key because it does not even have data of its own. So it is very compulsory, right, that your tables, as long as they're going to be referenced somewhere else, as long as they're going to be giving us more information somewhere else, they have to be what? They have to be referenced. You have to put a primary constraint on them, and they also have to be referenced, right? Somebody wants to say something, please.
No, it was me, sir, but you answered what I wanted to ask. So no problem.
Okay. All right.
Hi, Mr.
Any
Chairman.
question? Yes, talk to me.
Okay, so I have two questions. The first one, can a populated table be altered? Like after you
Yes, of
complete,
course.
you've locked it in, can you still alter it?
Yes, you can alter a populated table. Yes. But when you're altering a populated table, you make sure that what take for example, in populating a table, say take for example, I populated a table with integer data, right? Say I have a table, perfect. Let's use the example here, right? So I have a table that is S. Let's go through it, right? I created a table called S. Let's see. I created this table called look at it. Let's use this one. This T underscore code column is a character column, right? I can alter, and I've inserted values into it. Of course, I can change this to varchar, right? And it will work. But I cannot convert this to numeric, to integer, this code, right? If I'm going to convert this code to integer, what it means is that I have to first of all delete this code, this column. I have to drop the column and recreate it, and now add new values into it. Remember that if you're already that's one of the conditions that we put into place, right? When you are creating a table, right? So you see that creating table is not just a process where you just jump into it and all that. You have to be able to think through your values and say, what will these values be? So that tomorrow the values will not go and change. Imagine that you have 1 million data already in that column. Say T code is now 1 million data, right? And so all of a sudden, Tinubu just came in and said that no, the T code cannot be car, it has to be integer. There's problem already, because we need to hire people that will now adjust that value. But what we have to do will be to drop the column and recreate it with an integer column. But when it is that I'm saying that it is an integer column, yeah, right? And it wasn't unsigned. I mean, it wasn't signed before. I mean, the data type length was not specified before. I can always extend the data type, right? Like this one now. Take for example, let's say that the varchar. So we say the length of the name is 40. All of a sudden, they went to go and bring somebody from Iceland, and Icelanders used to have long name, right? And we need somebody, and we have somebody whose name is about 45 or 50 characters, right? I can now adjust this table, this column, by extending the length of the data type. But when you are changing the data type entirely, you have to drop the column and recreate it. Does that make sense?
So recreating the column means you have to start afresh. Like
no, you are only starting on that particular column, yes, not the old table, just that column.
Okay, but it doesn't affect what is in the table, like what is on that particular the table under that column.
It affects it, of course. If you drop this column, if I drop this column now, what it means is that the table becomes what? The table that was four columns before now has 3 columns. So it means that this column is gone. Of course, it affects the column, right? So if you want to bring back the column, it just means that you have to recreate the column and give it a new data type. So take for example, let me give you an example. So table T, hold on, so that you understand, right? Hold on. Table T has table T now. We want to drop the T code column, right? It has data in it. We want to drop the table. So we say what? Alter table, sorry. Alter table T. Drop column T underscore code. Right? Before we do that, where's our table T? Can you see? Table T is what? That's forward. That's 4. So that's 4 columns. If I run this now, right, I will say select all from table T. Right? The code column is gone. So if I want to re-add it now, I have to I have to alter that table. T and add column, right? T underscore code, right? But this time around, instead of what? Instead of car, it's going to be integer, right? Unsigned, right? So before it was what? It was a character column, but now it's not. Now it's what? It's it's an integer column. So if we say select all from T now, what you discover is that the column exists, but there's no data in it. So you now have to put data in it. Meanwhile, before it has data in it. But because the data that is in it before were character column, you cannot convert them to what? To numeric column or to integer values. Hence, you have to drop it and recreate it. Now you have to now write what? Alter tables can be update what? You now have to write update statement to add values into that column. You see that is work. I know that it is the work part that is scaring you. Yes, it is work. I would not like to.
Okay, thank you. My second question was when, like, for instance, the schema we were using under patient, let me say patient for instance, and then you're referencing doctor's ID from the doctor's table. On the patient's table, since we're going to be using the referencing from the doctor's table, do we need to put like a constraint? Can we just write maybe VACHA, or do we still need to put not to leave that constraint empty, since we're still going to be referencing from the doctor's table already? Like, do we need to put anything there, or we can just leave it at that?
I'm trying to get the question. Let me, I think I have the schema you're talking about. This schema.
Okay, we can use it, for instance. I'm saying, like, in a situation where.
Hold on.
Okay.
Patients, this one.
Yes, like we already have like the doctor's table. So obviously we're going to be Yes, we're going to be referencing okay, there's no doctor ID on patient. Okay, let me use province ID. And we already have the province table to be referencing from. Yes. So when we already put char, do we need to put not null? Because we can't add a constraint. We can't put primary key there. We can, I don't know, must we put not null, or we can just leave it at char two and then go to.
What you need to understand is that you can put when you are creating your table, right? Nothing stops you from putting your primary key, right? But you can create it either while you are creating your table. You can add your primary key while you are creating your table, or afterwards, right? But yes, you can put not null. If you don't want to put what's it called now? If you don't want to put your primary key, and you want to make sure that there's values in all your columns, right? In all your rows, so that you can use that column as a primary key eventually, right? You can put not null, so that at least there won't be empty values in the column. So that when you now want to reference, because when you have empty values, primary key does not work with empty values or null values. It's going to give you an error. Are you following me? So you can use not null to enforce that values are inserted into that particular column, into that particular column, such that when you are now ready to put your constraints, right, it will be easier. Do you understand what I'm saying? Yes, you can do it that. But the ideal way is that when you're creating your tables, right, and you have identified the column that needs to be primary key, add your primary key straight. It does not stop anything. Makes sense?
Yes, thank you. I just thought you can put primary key on a particular table more than once.
Yes, you cannot. No. Once the primary key is already on the table, right? You cannot You cannot have two primary keys on the table, right? Even those, there are some SQL DBMSs that actually allows that, right? Right. But it's not general practice. Hold on. Right? It's not general practice. You can put a primary key on a column and move on, right? You can put a primary key on a column and move on. It is when you need to reference it that you reference it. If it does not need to be referenced, primary key can be on a column without being referenced, right? If you don't need to reference it, there's no need for referencing. But it is important that you have a primary key on a column so that all your values in that row can be uniquely identified. That's basically the essence of primary key. But of course, we now leverage them for referencing when you want to link two tables together, right? So you can put primary key on a column. You can decide not to put it. It depends on the nature of that database. It depends on what the database really, really entails. Do you understand?
Okay, thank you.
All right. Iceman.
So with what you explained earlier on, or if you want to make correction on column, that we should drop the column first. Can't you just use more device instead of dropping the column?
The reason why we are dropping the column, the reason why I said dropping the column, is that when the data type does not match, the first column, in the first instance, the first column was, what's it called? The first column was, now, two things are making us drop the column. The column already has data inside of it, right? If the column has data inside of it already, you have to drop it. How many rows do you want to modify? 1,000,000 rows, right? It's because it is 4 rows, that's why you can see you can modify, right? We are dropping the column because why? The data type in there before was char, but now we want to what? Make it what? Integer. Are you following me? Right? That is one. Two, because now the challenge is that the reason why we are dropping it is that if the column already has data inside of it and it is a character column, right? And you now want to turn it to integer, it will not allow you modify it because it tells you that there's a clash in the data type. That's why you are dropping it.
All right, sir. Thank you, sir.
Yes, sir. Any
Well
other
done,
question?
sir. I have a
Wow,
question.
today's fire. All right.
Yes, sir.
So
Sir,
we just
can
need
you-
somebody to bed the cat. Now you want to kill me with question. Continue. Okay. All right.
Well done, sir. Please, can you explain the importance of index and how to create it with our table?
Okay. So indexes are used to improve the performance of query. Right? Indexes are used to improve the performance of query. My go-to example for indexes would be that God indexed us, male and female. Then God indexed us with our fingerprints. So when they are looking for, when they say there's a robbery somewhere, right, and they have 10 suspects, 20 suspects, and they have the evidence of the theft in terms of fingerprint, they don't need to arrest everybody, right? They don't need to jail everybody. They just need to be able to match that fingerprint that they saw to the fingerprint of the person that they have. It is indexing. God indexed us. You and I are different, right? So when you have a primary key column, right? That's why when we see when you create a primary key constraint on a primary key on a column, right? It creates a primary index on that column. Basically, what that means is that every column is unique. So if I'm looking for that column, take for example, we are 213 million people in Nigeria. If we have a database where our data is stored and I'm looking for your NIN, right? It will run faster. It will not have to look at all the 230 million people. It will only go directly to that particular person's NIN because there's an index on that column. But if there is no index on the column, I've told you that what? It will have to go one after the other. It's like saying that you have only one blue shirt in your wardrobe and you ask your son, Larry, go and get me my blue shirt. Will he go and he knows what blue is? Do you think he would open the wardrobe and begin to look at all the clothes there one after the other? No. Index is that color. So he's just going to go to that color and pick it out. What happens? It's going to go in like one minute or two. But if you have plenty white shirts and you said, Larry, go and bring me that white shirt that has that stripe something. What happens? He begins to look at them one after the other. What happens? The rate at which he's going to come back with that shirt is going to be longer. Because why? He has to go through each of the items. But in terms of index does not have to go through, it doesn't have to loop through all the items. It just goes directly to the value that you have called. So that's why we create index on data, right? We create index on data. And I've showed you, let me show you. We've talked about index before. Index, we said it was improve what query performance. And we use the create index. Correct. This is it here. Right? Look at it. Create index. Name of the index. This is a composite index, right? So you can create index and All right. Yeah, I have what? I have the T table. So I can say create index. T underscore IDX on T. What column of T table? I want to create it on the TID. Right. So I'm adding now. Okay. So we have TID column. There's a primary key on that column. So I'm going to say on the T underscore code. Right. Right. So if I run this now, the index is created. So if I say show index from T table, can you see? It tells me that there are two indexes on the T table. The first one is the primary key index on the what? On the TID column. Look at the one I just created, T underscore IDX, on what? On the T code column. So what it means is that if I write a query on these two columns, using any of these two columns, my query is going to run faster than normal. If I write, remember that table has what? That table has 4 columns. If I write a query on the T name column, it's going to be slower compared to what? To the ID and the what? And the T code column. That's basically the essence of index. So it makes your query run faster. It improves the performance of query. That's what it does. Make sense?
Yes. Thank you so much, sir. Thank you.
Yes. Any question? Any other question? It's 9:09. Any other question? How many questions have I answered today? Okay. Any other question? Talk to me. Any other question?
I have a question, sir.
Okay.
Based on this primary keys and foreign keys, like when I was adding, when I was populating the tables, like I found out, like you said the let's say if the product ID in products table and in others table, the values have to be the same. So
Yes, sir.
I later realized that I didn't put the same I didn't put the same what's it called, data type.
Values. The same data type on the two columns.
Yes, I didn't put the same data type.
If you don't put the same data type, then it means they cannot be linked.
So I have to alter it.
Yes, you have to alter it. You can't if they don't have this. The condition to see the essence of these things is that I explained it like this when I was teaching you guys, right? I said that I'm not sure if it was for you. I'm not sure if it was a class, right? Let's use this example, right? Remember that we call it a relationship. The primary key, and when you're joining two tables, right, it's a relationship between them, right? Imagine that, of course, Nigeria is a multicultural environment, multi-ethnic environment, right? If not because nowadays, civilization has made things easy. It would be very difficult for an Hausa man to marry a Yoruba man. It would be very difficult for an Igbo man to marry an Hausa man or to marry a Yoruba woman, right? Why is it difficult? It's because they don't understand each other. They cannot understand each other. Language-wise, they don't understand each other. Cultural-wise, they don't understand each other. And that's basically what you have when you have two columns that you want to join together that does not have the same data type. If you look at it, I've told you that there are two conditions to it. They must have the same name, but the same name most of the time is not compulsory in the sense of this situation, right? I showed you an example of it here. Look at it. Doctor ID. Look at the doctor ID on this table has become attending doctor ID here. Doctor ID on the doctor's table became attending doctor ID, but it's the same data that's inside of it. Data integer. So it's not compulsory that they have the same name. There's another example in this next one, right? where we have, where do we have it? Yeah, shipper ID became what? Ship via. It's the same. Can you see that they have the same data type? Right? Even though they are not from the same word, even though they are not from the same culture, right? We're saying that at least they are human beings, they can marry each other, which is what is happening in this time and day, right? So basically, when you are joining two, when you want to create a relationship between two tables, and when you want to use a column for a relationship between two tables, they must have the same data type. It's very important. The same name is not even important. They don't necessarily have to be the same name. The reason why we say they must have the same name is so that you can identify them, right? But it's not compulsory that they have the same name. But the data type, they must be the same. Makes sense?
So then there are some that have same data types, but I use the constraints were different.
The constraints are different. How?
Let's say probably in one I use. Can you hear me, sir?
I can't hear you very well. I can't hear you very well.
Okay. Can you hear me now?
Hello?
Hello, can you hear me?
Hello?
Can you hear me, sir?
Yes, I can hear you now.
Okay. I said like
I can hear you now. Yeah.
Okay, sir. Like in one table, I might have integer unsigned for the same column.
Mm-hmm.
Then in another table, I might be having probably integer with 4 characters. And
Now the thing is, okay.
when I was adding the values, you have different values. That was before I took note of the fact that they were, related. I had
So in
already
that situation now, in
I can't hear you, sir.
hello, can you hear me?
Okay, I can hear you now.
I say what you would do is that you need to edit. You probably have to edit the. You probably have to first of all edit the column. The data type must match. What basically this is another issue that usually happens, which is what I think you have in this situation, right? Even though one is integer with a length of 4 and the other is integer unsigned, right? It will work as long as the integer unsigned is not the values inside the integer unsigned does not exceed the value in the one that is integer of 4. That is why we say that so that you have avoid all this kind of problem. Make them the same data type, right? If you have values that exceed the value of 4 in one column and they are referenced to each other, it will cause problem. So what do? You have created your table, alter the table, and alter the columns on both tables on the tables, right? Alter the column on both tables, right, and make them have the same data type, such that the values can rhyme, right? If you have values in them already, you might not have to go and edit your insert after you have altered the tables and adjusted the data type. You cannot go and adjust the insert statement as well, so that the values can also match, right? It's very, very important.
All right, sir.
Yes, ma'am. Any other question before we wrap up? Any other question? Any other question? I hope today was a good class. I hope we learned a lot, right? This should help us solve our assignments. Any other question? Any other question before we move on? Right? Please engage the videos. The videos are
Mr.
online.
Sean.
Yes, ma'am.
Please, sir. I think my own HR is somehow is faulty somehow because I wanted to run some query on it, but it's telling me that it's not exist. For the fact that I've run it the day you said we should do that, but it's still telling me that
Yes.
the tables there is not exist. What can I do?
Let me. What can you do? Okay. What you can do is you drop the schema, drop that schema and recreate the schema. What do I mean? This is what I mean, right? It's saying that the tables does not exist. So basically, right, from the top of my head now, I'll say just run drop schema, right? Are you following me? Drop schema HR. Run this statement. It will delete the old HR schema.
Okay.
It will delete this HR schema, right? Then you can now what? Once that is done, you can now open this code, right, and run everything again. It will recreate the schema for you.
All right, sir. All right, sir.
Yes, ma'am. Yes, ma'am. Any other question? Any other question before we call it a day? All right. Tomorrow, I'm hoping that we would have finished our assignments tomorrow. But if not, I'm hoping that tomorrow we can continue, right? I'm hoping that tomorrow we can continue our classes on SQL so that we can wrap up SQL hopefully this weekend and start PowerBI next weekend, right? If you still have questions, I'm back on WhatsApp. Hey, people, I'm back on WhatsApp now. So you can reach out to me on the go. It doesn't have to be Telegram now, right? I have my phone back now. I've decided to come back online. My break is over. So you can reach out to me on WhatsApp and I'll answer you on the go, right? If you have questions, so reach out to me. If you have not submitted your assignments, please do, so that I can go through them this weekend and give you a reply so that we can move on. And I think we've had a good class today. Thank you for coming. I hope you learned something. I did not hear from Moyo. Why are the people that I did not hear from today? So, let me see. Moyo, Ola, Solomon. Those are the two people that I did not hear from. God is watching both of you. They are legends. That's what it means. You know, people that don't. There are some people that don't talk in class. They sabi book there, right? You are doing well. God bless you. All right. Oh, thank you for coming, everyone. I wasn't expecting that this class was going to be this long. I wanted to give us a break, but it's good that we answered all the questions.
Thank you.
Yes, thank you so much. Thank you. Do have a wonderful night, everyone. See you tomorrow evening. God bless you. Bye.
Bye.
Yeah, thank you,
Good
sir.
night. Good night.
Bye. Good
Yes.
night.
Hey, finally, say something.
Thank you, sir.
Good night. Good night.
Thank you.
Good
Good night, sir.
night. Good night. Good night. Thank you. Good night. Regards to your family. Good night.